In the previous example presented to the class, we investigated the collapse of the World Trade Center 7, and in the process, we demonstrated the interdisciplinary nature of the fire engineer. This is where the fire engineer needed to have a general knowledge of the mechanical systems, the fire protection systems, passive fire protection systems, and the structural system. Now again, in this example, we are going to reinforce this requirement of the fire engineer to have a broad range of knowledge. The following video aims to demonstrate knowledge of material science. As the fire engineer, we need to understand that it is not only about the individual materials and that the individual performance of those materials does not necessarily shed light on the combined performance of a system. For this experiment, we're going to use 3 materials. First, we have a single 9-volt battery. A battery is a form of energy but is constructed generally of metal and by itself does not generate a fire. Second is a metal wool pad. As the name suggests, the material is metal and hence would commonly be deemed as being non-combustible. Third and last is a cotton ball. This material is combustible, but generally an initial flame or heat is needed to start the combustion process of the cotton ball. So how can we use these 3 materials to generate a fire? Let's try some combinations. Looking at the steel wool and the cotton ball, nothing happens. This is as expected, as both materials are non-combustible. Looking at the battery and the cotton ball, again as expected, nothing much happens. The cotton ball, although combustible, is unable to release the energy of the battery. Now let's try the metal wool and the battery. A little something more interesting happens. We can see a few sparks occurring. The steel wool is dissipating the electrical energy through individual wool strands, and as it does, due to a degree of material resistance or lack of capacity in an individual strand, the electrical energy causes the metal to heat up and glow. However, this does not last very long, as the majority of the steel wool is tightly wound, which allows for greater capacity to dissipate the energy and hence reduces the heat buildup in the wool and stops the spread. So now we have a process of using the battery and the metal wool to generate heat. And we know from the material understanding of the cotton ball that it is combustible provided that it is given an initial flame or heat source. So how do we harness this process of electrical dissipation and heat buildup within the metal wool and transfer that to the combustible cotton ball? First, unroll the metal wool. This separates the metal strands, hence reducing the immediate capacity for electrical energy dissipation. Next, place the cotton ball within the separated metal wool. In this example, I have separated the cotton ball also, only to better enable the process. The final step is to simply make light contact between the metal wool and the battery. The electrical dissipation starts and the individual metal wool strands heat up and glow. This process continues until sufficient heat builds up to the point of ignition of the cotton ball. What have we learned here? We have learned that as fire engineers, we need to understand not only the material characteristics of individual components, but we also need to understand how the different components, when combined in particular ways, may react together. This concept becomes particularly important as we move through this course and when trying to unravel the issues that we are facing today with fire engineering and modern facade systems.